You can indeed use a terminal block to reduce the size of the cable at the connection point. A terminal block is an electrical component that provides a safe and convenient method for connecting multiple wires. It typically consists of an insulated block containing metal terminals designed for wire connections. The impact of using a terminal block with a smaller gauge wire at the breaker end on voltage drop is minimal, assuming firstly the terminal block is rated for the circuit's current capacity. Secondly, the wires are securely connected to the terminals with the correct torque. Thirdly, the terminal block is enclosed in a junction box to protect it and ensure proper ventilation. Voltage drop is primarily influenced by the length and size of the cable itself, not the connection point. By using a larger wire gauge, such as 2/0, for the majority of the circuit, you've effectively minimized voltage drop. The short section of smaller gauge wire at the connection point will have a negligible impact on the overall voltage drop. For a 100 amp subpanel, a copper terminal block rated for at least 100 amps is appropriate. Ensure that the terminal block has enough terminals for all necessary connections. Here are the steps for using a terminal block. 1. Strip the insulation from the ends of both the larger gauge wire, for example, 2/0, and the smaller gauge wire to the length specified for the terminal block. 2. Insert the stripped wire ends into the corresponding terminals on the terminal block and tighten the screws to the specified torque using a torque screwdriver. 3. Connect the terminal block assembly to the breaker or other intended device. 4. Enclose the terminal block within a suitable junction box and securely mount it to the wall or panel. The use of a terminal block to connect a smaller gauge wire at the breaker end is acceptable when voltage drop is a consideration. This allows you to use the upsized cable for most of the circuit length while facilitating a secure connection at the breaker. When dealing with electrical work, always prioritize safety and adhere to local electrical codes. If you are not comfortable performing the work yourself, consult with a qualified electrician. Using a terminal block does not defeat the purpose of upsizing the cable to mitigate voltage drop, provided it's done correctly and the terminal block is appropriately sized for the load. The primary goal of upsizing the cable is to reduce resistance over the long run, minimizing voltage drop. The short length of smaller gauge wire connected via the terminal block has a negligible impact on the overall voltage drop. However, it's crucial to ensure proper and secure connection at the terminal block to avoid potential issues such as overheating or loose connections. Always select a terminal block with an amperage rating equal to or greater than the breaker size, protecting the circuit. In the scenario described, using a 100 amps rated terminal block is appropriate for a 100 amp subpanel. Ensure the terminal block is also listed and approved by a recognized testing laboratory, such as Underwriters Laboratories or ETL/SEMCO, to meet safety standards. When connecting the wires to the terminal block, use the correct torque settings specified by the manufacturer. This is essential for creating a secure connection and preventing the wires from loosening over time. A loose connection can lead to increased resistance, heat generation, and potentially a fire hazard. Furthermore, enclose the terminal block within a suitable junction box to provide physical protection and prevent accidental contact with live terminals. The junction box should be made of a non-combustible material and securely mounted. If the terminal block is located outdoors or in a damp environment, use a weatherproof junction box to protect it from moisture and corrosion. Remember that voltage drop is affected by several factors, including the length of the circuit, the current flowing through the circuit, and the resistance of the wire. The longer the circuit and the higher the current, the greater the voltage drop. To minimize voltage drop, use a larger wire gauge, reduce the length of the circuit, or reduce the current flowing through the circuit. The National Electrical Code, or NEC, provides guidelines for calculating voltage drop and selecting the appropriate wire size for different applications. Consult the NEC or a qualified electrician for specific recommendations. Also, remember that aluminum conductors have a higher resistance than copper conductors, so a larger size aluminum conductor will be needed. Aluminum conductors can be a cost-effective alternative to copper, particularly for long runs. When working with aluminum conductors, use connectors and terminals that are specifically designed for aluminum. These connectors are typically made of aluminum or bimetallic materials and are designed to prevent corrosion and ensure a reliable connection. Also, apply an antioxidant compound to the aluminum conductors before making the connection. This compound helps to prevent oxidation and corrosion, which can lead to increased resistance and heat generation. When connecting different metals, such as copper and aluminum, it is essential to use connectors and terminals that are designed for dissimilar metals. These connectors are typically made of bimetallic materials and are designed to prevent galvanic corrosion, which can occur when two different metals are in contact with each other in the presence of an electrolyte. When installing a subpanel, it is important to follow all applicable electrical codes and regulations. These codes are designed to protect people and property from electrical hazards. Obtain any necessary permits before starting the work, and have the installation inspected by a qualified electrical inspector to ensure that it meets all applicable codes. In addition to voltage drop, there are other factors to consider when selecting the appropriate wire size for a subpanel. These factors include the ampacity of the wire, the ambient temperature, and the dirting factors specified in the NIC. The ampacity of a wire is the maximum amount of current that it can safely carry without overheating. The ampacity of a wire is determined by its size, insulation type, and the ambient temperature. The NEC provides tables that list the ampacity of different wire sizes and insulation types at different ambient temperatures. Also, ambient temperature affects the wire. If the ambient temperature is high, the ampacity of the wire will be reduced. The NEC provides dirting factors that must be applied to the ampacity of a wire when it is installed in a high-temperature environment. In addition, wires must be derated when there are multiple current-carrying conductors bundled together. The NEC provides dirting factors that must be applied to the ampacity of a wire when it is installed in a conduit or cable with other current-carrying conductors. When selecting the appropriate wire size for a subpanel, it is important to consider all of these factors to ensure that the wire is capable of safely carrying the load. Also, the subpanel itself should be rated appropriately. The subpanel must have a sufficient number of circuits to handle the loads that will be connected to it. The subpanel must be located in a readily accessible location and must be properly grounded. When installing a subpanel, it is important to follow all of the manufacturer's instructions. These instructions provide detailed information on how to install the subpanel safely and correctly. If you are not comfortable performing the work yourself, consult with a qualified electrician. When connecting wires to a breaker, be sure to use the correct torque settings specified by the manufacturer. This is important for ensuring a secure connection and preventing the wires from loosening over time. A loose connection can lead to increased resistance, heat generation, and potentially a fire hazard. Many breakers are designed with torque specifications printed directly on the breaker itself. Use a torque screwdriver to achieve the proper torque, and check the connections periodically to ensure they remain tight. If a breaker terminal is not labeled with a torque specification, consult the manufacturer's instructions or a qualified electrician for the appropriate torque setting. In addition to using the correct torque setting, it is also important to use the correct type of connector for the wires being connected to the breaker. For example, some breakers are designed to be used with only copper wires, while others can be used with both copper and aluminum wires. Using the wrong type of connector can lead to corrosion and other problems. Always check the breaker's specifications to ensure that you are using the correct type of connector. When working with electrical systems, it is always important to prioritize safety. Always turn off the power to the circuit before working on it. Use insulated tools and wear appropriate personal protective equipment such as safety glasses and gloves. If you are not comfortable performing the work yourself, consult with a qualified electrician. It is also important to be aware of the potential hazards associated with electricity. Electricity can cause serious injury or death. Never touch bare wires or electrical components. Always assume that electrical circuits are alive and take precautions to avoid contact with them. In addition to the terminal block and wire connections, the grounding system of the subpanel is critical for safety. The subpanel must be properly grounded to provide a path for fault current to flow back to the source, which will trip the breaker and energize the circuit. The grounding system typically consists of a grounding electrode conductor, a grounding busbar in the subpanel, and equipment grounding conductors that run with the circuit conductors to each outlet and device. The grounding electrode conductor connects the grounding busbar in the subpanel to a grounding electrode, such as a ground rod or a metal water pipe. The grounding electrode provides a low impedance path to ground, which helps to limit the voltage in the electrical system during a fault. The equipment grounding conductors provide a path for fault current to flow back to the source from any faulty equipment or appliances. These conductors are typically bare copper or green insulated wires. When installing a subpanel, it is important to follow all of the NEC requirements for grounding. This includes properly sizing the grounding electrode conductor and the equipment grounding conductors, and making sure that all connections are secure and corrosion resistant. It is also important to bond the subpanel enclosure to the grounding system. This helps to prevent the enclosure from becoming energized during a fault. Bonding involves connecting the metal enclosure of the subpanel to the grounding busbar with a bonding jumper. The bonding jumper should be sized according to the NEC requirements. When working with electrical systems, it is always important to be aware of the potential hazards and to take precautions to avoid them. By following all of the safety guidelines and NEC requirements, you can help to ensure a safe and reliable electrical system. Furthermore, consider the type of loads you anticipate connecting to the subpanel and the shed. This will help determine the necessary amperage and the number of circuits required. Common loads in a shed might include lighting, power tools, and small appliances. Plan for future expansion by including additional circuits or a larger subpanel than initially needed. This will provide flexibility for adding more equipment later without having to replace the entire subpanel. It's also crucial to protect the wiring between the main panel and the subpanel in the shed. This can be accomplished by running the wires in conduit or using direct burial cable that is rated for underground installation. Conduit provides physical protection for the wires and prevents them from being damaged by rodents, weather, or accidental digging. Direct burial cable is designed to be buried directly in the ground without conduit, but it must be buried at the proper depth and be protected from physical damage. Consider the local climate conditions when selecting the type of wiring and protection. In areas with harsh winters or frequent flooding, extra precautions may be necessary to protect the wiring from the elements. Always consult with a qualified electrician to ensure that the wiring is installed safely and in accordance with local codes. Remember, proper planning and installation are essential for a safe and reliable electrical system in your shed.